Welcome back to Seacoast High School's remote trigonometry class. My name's Eric Fearing. I use he, him pronouns, and most of my students call me Mr. This video begins a sequence of 4 about Competency 2, Benchmark 3. Competency 2 is all about using trig in acute and obtuse triangles instead of just right triangles. And Benchmark 3 is about the laws of sines and cosines. This video addresses finding angles using just the law of sines. The law of sines is the sine of A over A equals the sine of B over B equals the sine of C over C. This just tells us that there's a proportion between the sine of an angle and the side across from it in any triangle with any other pair in that same triangle. So we're going to do an example and then go to something like the homework. So here's a triangle ABC, where we only know one of the angles is 30 degrees, which is pretty clearly drawn to a bad scale, but that's okay. If that side is 30 degrees and if that angle is 30 degrees and the side across from it is 12, we would call that angle A and side little a. So one of the fractions in the law of sines would tell us that the sine of 30 degrees over 12 is going to be equal to the other two potential fractions we could make, which have to do with the sine of angle B over the side across from it, 15, or the sine of angle C over the side across from it, which we don't know. So if we don't know either the angle or the side across from it, we cannot use the law of sines to find that missing piece. So the only thing we have enough information to figure out in this triangle is the measure of angle B. So the sine of B, whatever it might be, divided by 15 is going to be equal to the sine of 30 over 12. Now we just have to solve that proportion and use an inverse trig function to figure out what angle B itself is. Our variable is on the right. It's in the numerator of our fraction. I'm going to multiply both sides by the denominator of the fraction. Technically 15 over 1, and 15 divided by 15 makes 1. So we know the sine of B will be equal to 15 times the sine of 30 degrees over 12. And for this, we can just go to our calculator. We can reduce it a little bit because 15 and 12 are both divisible by 3, but rather than do that, I'm going to go right to desmos.com/scientific so that we can find out the exact answer here. Well, technically it's not an exact answer once we've gone to a decimal and rounded things off, but we'll see. 15 times the sine of 30 degrees over 12. We can just take the sine of 30 degrees and replace that in our fraction if we wanted to. The sine of 30 is exactly 0.5, so we could in fact get an exact answer for this problem. But there's no need to do that necessarily. We can instead put in that fraction as it is. 15 times the sine of 30 degrees is 7.5 in the numerator, divided by 12. Be careful about your order of operations. The way that the calculator builds the fraction might be a little odd. If you've got a calculator at home or a calculator app on your phone, you might be a little easier to use than this. But I know anybody with a Chromebook can get through here. So here we have 15 times the sine of 30 over 12 equals 0.625, which is actually 5/8 exactly. 0.625 is the sine of B. We could record it as 5/8 is the sine of B. But what we want is the measure of angle B on its own, not the sine value of it. It's good that we got a proper fraction or a decimal between 0 and 1 because that's how sine is going to work. But to get our final answer, we want to take the inverse sine of that answer. And that will be an estimate. So on Desmos.com, hit function, inverse sine, and then you can go back to the main tab, and instead of keying in 0.625 or 5/8, you can put in answer, and it will populate it with the answer from your previous question. And now we can see 38.68 is going to round to 38.7 degrees. We would expect angle B to be a little larger than angle A because the side across from it was a little larger. So that's a reasonable, believable answer, 38.7 degrees. That total of those two angles is very low, so our drawing here is to terrible scale. We would need a really big angle at C to make 180 total degrees. These were probably more like 60, 70 degree angles. So I'm going to do one more. All of the problems are set up this way, where you have just the right amount of information. So we need to write our two fractions that are going to make up our proportion for the law of sines. We're going to find the measure of angle M, which is here, and that's across from side M, which we'll recognize as 16. So the sine of M over 16 will equal, we know 23 degrees is angle J, the sine of 23 degrees over the side across from J, 10. So there's our proportion. Again, to solve this, we're going to multiply by the denominator of the fraction with the variable in it. 16 divided by 16 is 1. So the sine of M is 16 over 10 times the sine of 23 degrees. And whatever that comes out to be, I know M is going to be the sine inverse of all of that stuff. 16/10 sine of 23 degrees. Probably easier to do this on the calculator and think about it as just a decimal number in there. So let's do that. 16 divided by 10 is going to be 1.6. We're going to multiply that by the sine of 23 degrees and get almost the same thing we got before, but 0.625169, etc. So M is approximately the sine inverse of 0.625 and so on, just a little bit larger than when it came out to exactly 0.625 in the last example. I'm going to hit enter so that that's my answer, and now take the sine inverse of that answer and get 38.7 degrees. So we just used the law of sines to find a missing angle, which means writing a proportion with two of the fractions appropriate to your triangle, solving to get the sine value alone first, and then taking the inverse sine to find the missing angle measurement. Good luck on the homework. If you have any questions for me, you're welcome to contact me via Google Voice, text message, or email, and can always come to office hours at 1 o'clock on Tuesdays and Thursdays. Thank you.